In this episode, we'll be checking to see if your components measure up.
Okay folks, today we're gonna inspect our cam and our crankshaft to see how much wear there is on it, and that will determine if we buy a new one, because it's not worth fixing a camshaft. They're about 150 bucks. A crankshaft, it is worth it. They're much more expensive, and they can just grind down these journals, and then you put oversized bearings on them to account for the material you're machining away. So they can be refurbished, so to speak. Just buy a new one of these. I'm using calipers. There's two ways of measuring stuff. This is the brand I bought. It got really good reviews by some chap who was evaluating various calipers, and this one got a good review without. This was like 30 bucks, and then it jumps to like 150 bucks. So for that extra tenth of a thousandth, you really don't need it. All right, so save yourself some time. I'm not selling these or anything, just save yourself some time. You can also use a micrometer to do this. That looks like a C-clamp, and you adjust it and you read the vernier scale and this, that, and the other. They both work. I find this a lot easier to calibrate. You just clamp it on and it digitally reads out what's going on. And there you have it. So you pick the tool you want. So this couldn't be easier. I'm literally just going to zero out my scale, which it's not. Okay, it's one-handed. Sorry, folks. So I'm one-handed. Then you just put it on whatever it is you're trying to measure. All right, we're going to measure this journal right here. Now, this is an oil port, so make sure there's nothing like that in the area you're going to be measuring. So I'll just sit this down. And then you just, after this is zeroed, check it again, zero. Just expand it, and then just put a little bit of pressure on the clamps, and then read away. And do it in a couple of spots, because you might have had uneven wear. Like I got 1869. 1866. $1866 there. Yeah, consensus is looking like 1865. So 1865. Let's, for giggles, just move on to the last one. We're going to write down that value, 1865, but we're going to check this one here. Again, a little bit of pressure. That's 1865. It's 1866 or so. 1865. 1865. So I don't know what it's supposed to be yet, but I hope it's 1865. All right, let's check these guys. These are the piston journals. That's 1865. And that's 1866. So we've got some consistency here. Can't wait to find out what that's supposed to be. All right, we're going to do the same for the main bearings journals. Getting 2.12. Let's do this guy. 2.12, somewhere in there. 2.1. Let's do this guy. 2.15. So 2.12, somewhere in there. So again, this isn't rocket science what I'm doing here. I just want to know if they're close to what they're supposed to be. Okay, so when you're measuring a cam, what you got to do is take two measurements. You want to take a measurement at the minimum radius, which would be about here, 1.116, and then you want to take it at the maximum radius or maximum height, which would be here. And then you take those numbers and you subtract the small one from the tall one, and that gives you the amount of rise, or the amount that the lifter will move as this thing spins 360. And that's the number that you'll compare on the spec chart. And for MGB, it's supposed to be around 0.255. So that's how you do a cam. You need two measurements per lobe, the min and the max, and then you subtract them. And again, there's not a lot you can do on the cam. It's just not worth messing with them. Because when you get a new cam also, you get this gear, a new gear. You don't have to worry about these teeth being gnarly and terrible, because they run your distributor cap and other things. Let's go and find out what they're supposed to be, and then we'll know if we're in range, because what'll happen also is in the manuals, you'll also see a tolerance range. There'll be a high tolerance, low tolerance on what is acceptable that the engine will still run, right? You want them to be balls on, but they know that they're going to wear, and so they're basically telling this is the acceptable wear that will allow the engine to run well without burning oil or showing signs of wear. So we'll make sure that we're in that range, and I'm assuming we've exceeded that range, and we'll need the machining. So with all this talk of grinding and refurbishing, I thought I would explain better what that really means for those of you who don't really know when we talk about going O2 over, O2 under, these types of things. So in this first image, you're seeing an engine block where the crankshaft sits in those cradles, and you're seeing that the bearings are sitting in the cradles. Now, typically, the bearings are sacrificial, so you're supposed to destroy the bearings before you eat through and start destroying the engine block, which makes the engine block useless. So the cradle that the bearing sits in is a standard diameter, okay? And that matches the outer diameter of the bearing. Now the bearing has a thickness, and the ID of the bearing is basically the OD of the journal from the crankshaft. There is a minor gap in there for an oil film, but for our discussion, let's just assume that they're mating. Okay, we don't need the engine block anymore. We're just discussing the crankshaft and the journals on it, and then the bearings that mate to it. So in this first computer image, we're seeing a brand new crankshaft with brand new bearings. So for the main journals in this example, we're going to assume the outer diameter is exactly 2 inches. Therefore, the inside mating surface of the bearing is also 2 inches. Again, there is a small gap for oil filling. We're not going to deal with that to keep the math easy. In the next image, we're showing how one of the journals has worn down, and you can assume that the mating surface of its bearing has also worn down. But again, the bearing is sacrificial, so the block hasn't taken any damage, just the journal on the crankshaft and the bearing. So when you buy bearings, you can buy the standard size, which is as they come from the factory, or you can go in increments of 0.01 undersized, 0.02 undersized, 0.03 undersized, and you can get more and more, but there's a point where you really shouldn't exceed that value, and it's time to scrap the crankshaft. So we send our crankshaft off to the local machine shop, and they put it in a rig like you're seeing here, which is it's fairly interesting because the crankshaft has all these offset lobes, so you have to mount it in a fixture and then move the grinder out to meet the particular lobe, and then it just grinds down the amount specified. So in this next image, you're seeing in the light blue area that the crankshaft or that particular journal has been ground down the specified amount, which in our case is 0.02 inches. So now we buy the bearing that is undersized 0.02. And remember, the outside diameter of the bearing is still the same as the block. It's just that it got thicker by 0.02 to accommodate the 0.02 that we just ground off of the shaft. And in our final image, now you're seeing the machined journal, kind of the light blue surface, with now a much thicker bearing on it compared to the original bearing that you can see on the other journal. So still the outer diameters of all the bearings hasn't changed. It still fits exactly into the engine block. This is the same exact process and logic that you apply when you have cylinders that are scored too much. Again, you machine away the wall of the cylinder some amount till you get to good, clean material. And then you buy an oversized piston and oversized rings to make up that amount that you machined away. It's very easy to machine away or cut away material. It's very hard to add it. So that's why when I discussed the cam, since the cam is wearing down, you would need to add material to it to get it back to spec, which is a very involved, expensive process. Certainly the cost of the camshaft matters, and in our case it's about $100, so it's not a bank breaker, so you're better off buying a new cam. And speaking of lifters, the lifter is just a little cylindrical piece of metal that goes between the end of the push rod and the surface of the cam. And it helps to do a couple of things, but it mainly distributes the load over a larger surface of the cam. And these images are showing what a worn lifter looks like. And again, lifters are one of those parts that when they go bad, you don't really try to fix them, certainly on standard sized engines. I mean, mainly if you're perhaps if you're working on an engine in a ship or something huge, yes, you would machine it to fix it. But when we're trying to keep engine specs to standard so I can use standard parts, you generally don't machine things like lifters. And certainly for an MGB, just buy new lifters.
Now we know what machining needs to be done to the engine and what parts we need to purchase.